In this video, we are going to talk about curve fitting. Generally, we are given a functional relationship y equals fx. We assign value of x and find corresponding value of y and thus get coordinates of a number of points xi, yi. We plot these points on xy plane and get either a straight line y equals a plus bx where a and b are constants, or a curve y equals a plus bx plus cx square where a, b, c are constants. But sometimes instead of this functional relationship, we are given a set of values of x and y, and from these set of points we have to find functional relationship y equals fx, which may be a straight line y equals a plus bx or a curve y equals a plus bx plus cx square. So finding such a curve for a given set of values of x and y is called curve fitting. This curve, of course, is the closest possible curve to the given values. The curve so obtained does not pass through all the given points, but it is close to them to the maximum extent. The relation in general is assumed to be linear function y equals a plus bx or a parabolic function y equals a plus bx plus cx square, or even exponential or logarithmic. Let us learn more about this in detail. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Suppose we are given a set of points xi, yi, and we want to fit a straight line y equals a plus bx using these points. The straight line must be close to the given points to the maximum extent. For that, we use principle of least squares. Suppose given points are as shown in the figure. According to this principle, the line y equals a plus bx should be such that distance of the given points from the straight line measured along the y-axis must be minimum. The line obtained in this way is called the line of best fit. We will consider one of these points P to be xi, yi. The line parallel to the y-axis through this point P intersects the line in Q, whose coordinates then will be xi, a plus bxi, because equation of the line is y equals a plus bx. Now we have to find a and b such that distance pq is minimum, that is mod pq is minimum. Distance pq is this yi minus this a minus bxi. Now mod pq is minimum when square of this distance yi minus a minus bxi square is minimum. This is true for all the points. Hence we can write summation yi minus a minus bxi whole square is minimum. We find the values of a and b on the basis that summation s is the least. Hence this method is known as method of least squares. We have s equals summation yi minus a minus bxi whole square. From maxima and minima, we know that for this s to be minimum, we must have partial derivative of s with respect to a should be 0 and partial derivative of s with respect to b should be 0. Now dou s by dou a will be summation 2 times yi minus a minus bxi into derivative of minus a minus 1. Now this should be equal to 0. Cancelling this minus 2, this will be summation yi minus a minus bxi equals 0, which will be summation yi equals summation a plus b summation xi. Similarly, dou s by dou b will be summation 2 times yi minus a minus bxi into minus xi equals 0. Cancelling this minus 2 and multiplying by xi throughout, we get summation yixi minus a summation xi minus b summation xi square equals 0, which can be written as summation yixi equals a summation xi plus b summation xi square. We drop the suffix I and rewrite these two statements as summation y equals a being a constant. We write summation a as n times a plus b summation x. Similarly, here we write summation xy equals a summation x plus b summation x square. The equations that we have just found, summation y equals na plus b summation x and summation xy equals a summation x plus b summation x square, are known as normal equations. We will see how we can use them to fit a straight line to a given set of points. For example, suppose a set of points given are x comma y as 1 comma 1, 2 comma 5, 3 comma 11, 4 comma 8, 5 comma 14. We have to fit a straight line through this set of points. For that, we shall need summation x, summation y, summation xy and summation x square. We will prepare a table, values of x 1, 2, etc. and 5, values of y 1, 5, etc. and 14. Summation x will be 15 and summation y 39. Next we find x square 1, 4, etc. and 25, and summation x square will be 55. Next we find product xy 1, 10, etc. and 70, and summation xy will be 146. From first normal equation, we write 39 equals 5a plus 15b, and from the second normal equation, we write 146 equals 15a plus 55b. We name them 1 and 2. We solve these equations simultaneously to find a and b. Multiplying equation 1 by 3, we get 117 equals 15a plus 45b, and second equation 146 equals 15a plus 55b. Subtracting, we get cancelling 15a, 29 equals 10b, b equals 2.9. From equation 1, 39 equals 5a plus 15 into 2.9. 5a equals minus 4.5, a equals minus 0.9. From the values of a and b, we get equation of the line y equals minus 0.9 plus 2.9x, which is the line of best fit. That was direct method. When the values of x and y are large, this assumed mean method is convenient. For example, suppose values of x are 0, 5, etc. and 25, values of y 12, 15, etc. and 30. We assume convenient values of x and y as assumed mean. Here we assume 10 and 17 as the assumed means of x and y, and create a new value capital X, which is deviation of x from the assumed mean, that is x minus 10, and capital Y as deviation of y from the assumed mean 17, that is y minus 17. Now the new values of x and y will be 0 minus 10, minus 10, 5 minus 10, minus 5, etc. and 25 minus 10, 15. And here we find summation capital X to be 15. Values of capital Y will be 12 minus 17, minus 5, 15 minus 17, minus 2, etc. and 30 minus 17, 13. And summation capital Y will be 18. Next column, capital X square, minus 10 square, 100, minus 5 square, 25, etc. and 15 square, 225. And summation capital X square will be 475. Final column, product of capital X and capital Y, minus 10 into minus 5, 50, minus 5 into minus 2, 10, etc. and 15 into 13, 195. And summation capital X into capital Y will be 350. Assume the equation of the required line to be capital Y equals a plus b capital X. So the normal equations become summation capital Y equals na plus b summation x, and summation capital X into capital Y is a summation capital X plus b summation capital X square. From the first normal equation we get 18 equals 16a plus 15b, and from the second normal equation we get 350 equals 15a plus 475. Multiplying first equation by 5 and second equation by 2, we get new linear equations 90 equals 30a plus 75b and 700 equals 30a plus 950b. Subtracting, we get 610 equals 875b. b equals 610 upon 875, which is 0.7. Using this value of b in the first equation, we will get a equals 1.25. Now from these values of a and b, we write equation of the line capital Y equals a plus b capital X as this y minus 17 equals a, which is 1.25, plus b, which is 0.7, multiplied by capital X, which is small x minus 10, which after simplification gives y equals 0.7x plus 11.25 as the equation of the line of best fit. Y equals 0.7x plus 11.25. In deviation method, we find capital X by taking deviation of each observation x from the midpoint of values of x. Two cases emerge. First, when number of observations n is odd and when it is even. We will consider the first case when n is odd. We have values of x 0, 1, 2, 3 and 4. So in this case n is 5, which is odd. The mid value will be 2 and the deviation capital X of each observation from this mid value will be x minus 2. So 0 minus 2, minus 2, 1 minus 2, minus 1, etc. And we get summation x equals 0. Capital Y will be same as small y, and the corresponding y given are 1, 1.8, 3.3, 4.5 and 6.3. Summation capital Y is 16.9. Next column x square, minus 2 square, 4, minus 1 square, 1, etc. 2 square, 4. Summation x square is 10. Summation xy, minus 2 into 1, minus 2, minus 1 into 1.8, minus 1.8, etc. 2 into 6.3, 12.6. And summation xy, 13.3. Let equation of the line be y equals a plus p capital X. Working in the same manner as in previous examples, we will find a and b. A is 3.38 and b 1.33. Now by using the values of capital X, which is x minus 2, y, which is small y, and the values of a and b, equation of line becomes y equals 3.38 plus 1.33 into x minus 2. After simplification, we get y equals 0.72 plus 1.33x, which is the required equation of the line of best fit. For any value of x, say x is equal to 3.5, which is not given in the data, we can find value of y. In this case will be 5.375. Here it should be noted that when n is odd, the deviations are integers and hence the calculations become relatively easy. But when in the second case b, n is even, the deviations capital X are decimals and calculations become tedious. To make them simple, we will calculate x as 2 times x minus n upon 2th observation plus n upon 2 plus 1th observation upon 2. That will give values of x as integers and calculation becomes easier. Let us see how. Values of x are 1, 2, 3, 4, 5, 6. N is 6, which is even. Corresponding values of y are 83, 92, etc. Capital X will be 2 times x minus 3.5, where this 3.5 is average of 3 and 4. Here 3 is n upon 2th observation and 4 is n upon 2 plus 1th observation, and sum of them upon 2 is the average of 3 and 4, which is 3.5. So 1 minus 3.5 minus 2.5 multiplied by this 2 minus 5. 2 minus 3.5 minus 1.5 multiplied by 2 minus 3, etc. 3 and 5. Summation of x is 0. Similarly, capital Y is 2 times y minus 114.5, where this 114.5 is average y bar, which is summation y upon n, 687 upon 6. Accordingly, 83 minus 114.5 multiplied by 2 is minus 63, minus 45, etc. and 153. So summation y will be 0. The advantage of this is we get both summation x and summation y 0. That helps us in calculations. Next, we find capital X square minus 5 square 25, etc. and 25. Summation x square is 70 and final column product capital X capital Y. Minus 5 into minus 63, 315, etc. and 765, and summation xy will be 1526. We assume equation of the line to be capital Y equals a plus b capital X. By doing further calculations as in previous examples, we get a equals 0 and b equals 21.8 and equation of line y equals 21.5x, and after putting values of y and x from here and simplifying, we get equation of line of best fit as y equals 38.2 plus 21.8x. I hope you have understood the importance of considering when n is odd and when n is even. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.